All right, so there's my title because naming things are hard. So we do use exceptions in our code base, even though we are very concerned about performance. And I'll avoid the holy war about exceptions. But the other night at dinner with some folks, we were talking about it, and we were discussing why we use it and some things that we did in our performance testing originally. And so what I thought it might be interesting to share some of that stuff out. I'm going to make that bigger because that looks like it's too small. There we go. Okay, so this is on the left part, it's a function that we just made up. But it's just a function that uses a return code. You're just going to return a value from it. And as normal status stuff, right? It's just a stupid function, but it shows us what we want. And this is the code that it generates. So this is kind of what we want to get if we can create our throwing of the exception. A lot of times we talk about catching of exceptions. If we can get it to look similar to this, then that's kind of where we want to be. So let's see what we can do. In this case, we've replaced the returns with throws. And you can see here's the function, and it has grown tremendously. There's lots and lots of extra code there. Most of that is actually because when you call throw, it's going to inline all that code to actually create the exception and throw it. So let's try and get rid of that. So what we can do is we can have a function that we can have like a runtime error and a logic error function that will it's an external function that will actually, that you run so it doesn't get inlined. And now we can see that the code is very similar to what we had before. It's almost exactly the same. Not, give or take. And so what this is going to do, it'll at least save some iCache for us. But I don't like having these runtime and logic errors, basically having a function for every type of exception. So what can we do? Well, let's try templates, because that's what we always try anytime we have a problem. And so we write a template to. Oops, did I not go to the right one? There we go. So we have a template that raises the exception for us, and so we call raise. And what we do is we give it the type, and it does perfect forwarding, so we can give it all of its arguments, and it'll perfect forward the arguments to the exception. But we end up with all that same code again. It basically looks just like the throw. So what can we do? Well, if we use the attributes, we can then make this function be no inline, cold, and tell it that it's never going to return. And the code that gets generated looks just like the original stuff, except for there's your functions for your templates. But the code for the actual function is that right there. So you can, and to see the difference between the piece on the left, I can't really explode this up, but the piece on the left is the function that uses a status code and does a return of the status. The function on the right is the one that throws the exceptions, and they're pretty much side by side. You can see where they go. So the idea is that we don't want to pay for what we don't use. And that is both in execution instructions of what we're going to execute in the performance time, but also we don't want to have a bunch of code sitting around that we're never going to use except in exceptional situations. So there's a couple other things that we can do here. We can take our source location, and eventually the standard may or may not include this in some future version. But for now, what we can do is we can record our source location every time we throw an exception. We can call our raise. We have to use a macro. But in this case, if we call raise with the macro, we can include the line, function, and file. It will be set for every time we call a function, every time we throw an exception. And so then all we have to do is query and call current exception source location, every time we get an exception, and we'll actually get the file function and line from where the exception originated, which may or may not be helpful for you. One last thing, if I have time, I think I do. Oops, wrong one. All right, so this here down at the bottom, if you see, this is a loop. If you're gonna be catching exceptions is not a good idea. So just let your program crash. Not really, but there is a small expense for catching. So if you have a loop that's going to be running things over and over and over again, if you have your catch inside of the tight loop, you're going to end up generating this code over here. So what I do is I have an external for loop and then a try, and then inside of that, my for loop that does the stuff so that the catch is outside of that for loop. It'll throw an exception, it'll come out, and then if I still need to loop back up, I'll come back again, but then I only have that code path once. And there we go. Go make money throwing exceptions.